Now, this is a supporting videos for the gradient and intercept format. What we have over here is we have some questions about stating the gradient and y-intercept for the graphs of the following relations. I have part A, part B, and part C. Part C here. Okay. So what we're going to do is after we're going to name the gradient and y-intercept for first, and then I'm going to plot the line in the Cartesian coordinate. Okay, so if you have any trouble when doing this, you can come back to the video and look at how to do it step by step. Now, from our first one, now it's a pretty standard generalized equation format. If y equals to 2x plus 1, then we can write it as y equals to mx plus b. And what we can notice that is, if we compare the two equations, the coefficient that x is multiplied to is 2. And so our m is equals to 2. And the constant that was added on to the x term is equals to 1. So sorry, not b, this should be c. Okay, so the c is equals to 1. Now we know that the coefficient that was multiplied to the x term is called the gradient. So our gradient is equals to 2, and the constant that was added to the x term is called the intercept. So we already find the intercept and the gradient from the general equation in given class. Now part B, y equals to negative 3x. If we compare these to the general equation, we notice that our m is equal to negative 3. So this is the example of having a negative gradient. And there's nothing that was added on top of the minus 3x, so our y-intercept c is equal to 0. And don't forget, we need to say that this is our gradient and this is our intercept. Okay, now part C. Part C is a bit different from what we would recognize. If you say that the gradient of this linear equation is equal to 4, then you will be wrong, because if we compare to the general equation y equals to mx plus c, we notice that the it's not in the right format, so we need to rearrange it. So we have y standing on the left hand side by itself, and everything else need to be on the right hand side. So let's do that. Let's keep 2y over here, and if we want to move 4x to the opposite direction, we need to take away 4x from both sides of the equation. So it will be 10 take away 4x. Now, can I use this equation to compare with my generalized equation now? The answer is I still can't, because the y coefficient is not equal to 1. If I look at the generalized equation, there's nothing in front of my y. So the coefficient of the y term is equal to 1, because 1 times y equals to y itself. Now, our equation, the coefficient of y is equal to 2. So we need to make that coefficient be 1 first. 2 is multiplied to the y. Now, if we only want one lot of y, so we need to divide the whole term by 2. We need to halve it. After halving both sides, we have y is equals to 5 take away 2x. We can do that right now. We know that the coefficient in front of x is 2. Now, but the sign that's before the 2x is equals to minus. So when we talk about coefficient, we always include the sign that's in front of the number. Now, if you can't remember that, or you have trouble with doing that, let's change it to the completely same format as how our linear equation, as our general linear equation. So we have that y equals to, because we have the x term first. Now when we move in the term, we always need to include the sign that's in front of it. So that's going to be minus 2x plus 5. There's nothing before the 5, so it's a positive 5. Then we go as plus 5. Then the gradient of this equation, my m is equal to negative 2, and the y-intercept for this equation is going to be equals to 5. Now, my next part is to draw that linear equation. This is a linear equation, so the line is going to be a straight line, and we only need 2 points to allocate a straight line. So if I point 2 points randomly, and try that with your ruler, there's only one line that you can feed through both of them. So that's the way the concept we're going to use to draw our linear line. So we're going to find 2 points. Now the first point is going to be really easy to find because the first point we know that the y-intercept is equal to 1 by reading from the linear equation. So when on 1 over here, that's going to be my first point. So that's equal to 0, 1. My second point, that's up to me where do I want my second point to be. Okay, so my straight line is a collection of different points. The point of my x can change by itself, so I can just assume that my x equals to a number and find out what the y equals to, and then join the two lines together. So let's assume our y is equals to 2 or 3. Let's make our x equals to 2 for now. So when my x equals to 2, I'll put x equals 2 into the equation. The equation becomes y is equals to 2 times 2 plus 1. So y is equals to 5. So when x equals to 2, y is equal to 5. So I go 1, 2, 3, 4, 5. That's about over here. Let me get rid of the equation here. When x is equal to 2, y is equal to 5. So my point is about over here, 2, 5. So after I've got the two points over there, what I need to do is I need to feed a line through them. Now you can see that by doing this, by drawing this on the computer, I'm actually changing the graph a lot because I can't get the line through 2 points at the same time. Also, you can see that there's only one line that can pass through the 2 points at the same time. So that proves, or what we said in the previous, that 2 points will allocate a straight line. Now, after you have draw the graph, make sure that you have your 2 points that's being labeled, and also label your equation. So always write the linear equation, like the actual formula on your graph to get full marks. Now the next questions. The next questions, we have an interception point, y-interception point of 0. So you will pass through the origin over here, to pass through the point 0, 0. That's going to be one of my point. Now my other point, like what I said before, I can just assume that my x equals to the number. So I'm still going to just assume that my x equals 2, so you can see the difference. Let's write down the equation. Y is equal to minus 3 times x, and if x is equal to 2, I'll put 2 back into the equation. My y is equal to negative 6. So when x equals to 2, y will equal to negative 3, 6. Now 5, 6, minus 4, minus 5, minus 6. Then I go 2 over here and minus 6 over here. So my point is roughly over here. Now what I do is I will feed a line through both points. Okay. So let me compare these two lines. Our gradient are different and our interception point are different. But from the first question, our gradient is a positive number. So from left to the right, the line is traveling upwards. When we move on to the second equation, because our gradient is a negative number, so from left to the line, our graph is traveling downward. Now, let's look at our part C. If we are just plotting that from the 4x plus 2y equals to 10, it's not very easy. So what we're going to do is we're going to plot that from the equation that we have been reformed. So y equals to minus 2x plus 5. Now from this equation, you can give a guess if the line is traveling upwards or traveling downwards when we're looking at from left to the right. So after you have a basic idea how the graph will look like, let's start with plotting points. We are still going to start with the point that's on the y-axis. So we're going to start with the point 0, 5. So this is my 0, I go 1, 2, 3, 4, 5. My point is about over here. So that's when x equals to 0, y equals to 5. Oh, sorry, for the previous equation, I didn't write down what is my equation, what is the formula of the equation. Make sure you've done that. Okay, so back to our part. After we plot the point, now what we're going to do is we're going to assume our x value. Now I can assume any value. In this case, now I'm going to assume that my x equals to 5. Okay, so when x equals to 5, what does your y equals to 2? What does your y equals to? This is my where my x equals 5 is, and then we put x equals 5 into the equation. You have y equals to minus 2 times 5 plus 5, so that equals to negative 5, because it's negative 10 plus 5, so it's equal to negative 5. Now I'm just doing this because I already done the 5 over here, so it's easier for me to find other 5. It's going to be the similar distance. Of course, that you can choose any other numbers as well. You will find that your line still you'll find your point still lying on the same line, but just at a shortened distance in between them. So my this point is going to be 5, negative 5, and my next step is fit a line through the 2 points. Okay, now after I've done that, make sure that you write down the formula of your linear line next to it. So I will write down y equals to negative 2x plus 5. Okay, so that's how you find gradient and interception point from the generalized equation form, and then how to use the formula to plot a graph on your Cartesian coordinate.